Hello everyone, this video is about our paper, LangPose, Language Aligned Motion for Robust 3D Human Pose Estimation, accepted by WACV 2026. 3D human pose estimation from 2D inputs is inherently yield-posed, since multiple 3D poses can project to the same 2D pose. Most existing methods try to resolve this ambiguity by exploiting spatial and temporal consistency. While this works reasonably well in clean scenarios, performance often drops significantly when large occlusions occur, as important visual cues are missing. In contrast, action recognition provides high-level semantic information about the motion. For example, if we know a person is sitting down, the joint rotations are expected to follow a certain structured pattern. Importantly, actions can often still be recognized even under partial occlusions, since they rely more on global motion patterns than on perfectly visible key points. This suggests that action information is naturally more robust to occlusion and can serve as a useful prior for 3D pose estimation. Based on this intuition, we propose to first recognize the action and then use the inferred action information to guide 3D human pose estimation over the motion sequence. Based on this intuition, we propose a new framework that jointly recognizes actions and regresses 3D human poses. The motion sequence is first encoded using a pre-trained spatial temporal encoder to obtain motion representations. We then extract intermediate layer motion embeddings and align them with corresponding text bindings, allowing semantic information to be injected into the motion features. With this semantically enriched representation, the later layers of the model learn to regress the 3D human poses more effectively. To further encourage the model to leverage semantic information, we introduce two masking strategies, time window masking and body part masking. For time window masking, instead of masking individual frames, we mask a consecutive block of frames within the sequence. This prevents the model from relying solely on short-term temporal consistency and encourages it to use higher-level semantic cues to recover the 3D poses. Similarly, body part masking randomly removes information from specific body parts, forcing the model to infer the missing joints based on global motion semantics rather than local spatial correlations. In addition to the standard MSE loss between the predicted 3D poses and the ground truth, we introduce a novel contrasted loss that augments info NCE with both KL divergence and focal loss. This design is motivated by two practical challenges. First, motion long-grid datasets are typically highly imbalanced, where common actions such as walking are underrepresented compared to real actions. To mitigate the dominance of frequent classes and encourage the model to focus on harder or underrepresented samples, we incorporate a focal weighting mechanism into the contrasted objective. Second, the relationship between motion and language is inherently many-to-many rather than strictly one-to-one. A single motion sequence may correspond to multiple valid textual descriptions and vice versa. To better model this ambiguity, we introduced KL divergence to align the predicted similarity distribution with a soft target distribution, rather than enforcing a strict one-hot correspondence. The following video demonstrates the effectiveness of our proposed framework. In the original footage, the subject's knees are heavily occluded during the sitting down motion, making accurate 3D pose estimation particularly challenging. Both MotionBird and our method show robustness under this challenging scenario. However, MotionBird exhibits observable short-term jitter in the knee region, while our approach results in comparatively smoother and more stable motion. Thank you for watching, and I hope you enjoyed this video.